All right, my name is Jordan Taddick. I'm Territory Technical Manager with SolidWorks. And in just a moment, we'll be kicking off the SolidWorks MBD model-based definition portion of this afternoon's presentation. Now, the theme of this presentation is Grillin and Chillin with SolidWorks with Memorial Day weekend right around the corner. I hope you guys are enjoying the afternoon and have a light workload planned for tomorrow to enjoy your Friday and then kickstart the weekend with plenty of grilled food. So you see this this grill on the left-hand side of the screen. That is the theme of these presentations and the file set that we're using. It's actually from our advanced assembly class. So you could get your hands on it too if you go to SolidWorks' website and just download the model. All right, so let's talk about SolidWorks in SolidWorks MBD. And to do so, to put this in an appropriate frame of reference, let's think about how we are documenting our models that we're creating for manufacturing. So our goal is to create a 3D model in SolidWorks, and then from that, manufacture a 3D component. But for some reason, for the longest time, we are still creating 2D prints to communicate the detailed manufacturing information to the shop floor or to whoever's manufacturing this product. It really doesn't make any sense, but it's the way we've all been doing it for a long time, and such is the standard. But standards are actually changing, and common sense is taking over. And that is, there's no reason that we can't store all of our manufacturing data, dimensions, annotations, GD&T, tolerances, and all that stuff can be stored directly on the 3D model itself. To share that with others, we're not printing out a piece of paper, though we still could if we really wanted to. We could just go ahead and export this 3D model to either an eDrawings file format to review all these annotations, or to even a more shareable format, a PDF file, which everyone has installed some type of PDF reader on their workstation. So no software required to be installed whatsoever. So let's start by defining MBD. It stands for Model-Based Definition. And really, it's like I just explained, it's storing all of the manufacturing information, rather than in a drawing, in the model itself. So if you ever heard, the key abbreviations like, or acronyms, I'm sorry, like PMI, Product Manufacturing Information, 3DA, 3D annotations is commonly used in the automotive industry, and so forth. This is all part of a bigger trend, which is MBE, Model-Based Enterprise. And these are standards that are now existing in specific industries that I'll talk about in just a second that ensure and enforce people, designers, and suppliers to store all of their information pertinent to a project or a product in the 3D model itself. And that means if it's on the 3D model, then that is the gold standard for that project. That means it goes, and that is critical information for the project throughout the entire life cycle, from concept design to design work to the approval process to downstream purchasing, manufacturing, and so forth. All the departments are accessing the model and receiving and consuming their data from it. Now, the reason this is a trend is because industries like the military and the automotive industry are coming up with standards that enforce this. Here's why. This is a study that was done by the Department of Defense, our government. The numbers are pretty staggering, but you can imagine them to be true because detailed drawings inside SolidWorks take a heck of a long time to create. and they're not that fun to create either, right? They're the boring parts of our jobs. So why are we consuming so much time, 1/3 of engineering time and dollars spent creating these 2D drawings for manufacturing documentation? Well, the standards that are enforcing this are like MIL Standard 31000A for model-based enterprise and others. And it's these industries that are on the early end of the adoption curve. So MBD might not be something that you need to adopt today, but because the aerospace, automotive, military industries are always the trendsetters for the rest of us, you can guarantee, plus with all the common sense associated with this initiative, you can guarantee that eventually either a standard will make you have to consider it sooner than later, or again, just it makes sense to adopt it company-wide because it addresses so many more concerns that a 2D drawing cannot. So what's entailed with creating a 3D source for your manufacturing information rather than a drawing? Well, there's three steps. First, you need to define the information. Then you need to organize that information, and then put it into a format, a clear format that can be consumed by someone on the shop floor or someone required for manufacturing your product that you've designed. Now, for the design phase, or the define phase, I'm sorry, we're going to use a tool called DimExpert. And I'll explain later that DimExpert has been around for actually a really long time. It's a tool that you currently have today in every version of SOLIDWORKS, Standard, Professional, and Premium. So as I'm going through this demonstration, applying dimensions in the 3D space, know that this is functionality that you have today. So start at the top level of our assembly. There's a little keyboard shortcut, the G key, to open up a magnifying glass to make sure you're selecting the appropriate object inside of a large assembly. And down here at the bottom, because I have MBD installed, you can see that I have multiple 3D views. And as I activate those 3D views, the model orients to a new view, and specific dimensions and annotations are shown and hidden so that we don't cluster the view with way too many annotations, pretty much leaving us with a cobweb of dimensions that would just be way too overwhelming to consume out on the shop floor. So here I'm bringing in a note from my design library and positioning that on the screen in a specific orientation. And then all I'm going to do is recapture this notes view. And you'll see that as I click on one view and another view, those views will update automatically. Now the next thing that I'm going to do is create a right view. So in this particular view, what I'm going to do is use DimExpert to automatically detail these blue highlighted features, which are the holes on the end of this flange. You'll see immediately we get feedback of what dimensions or what faces in the model have been fully defined or not with that yellow and green highlighting, which faces are underdefined and which faces are not defined whatsoever. And then you could also see within just a few clicks of a button how I can add all the necessary dimensions to fully define that set of features for manufacturing purposes within the 3D model. So not only does DimExpert allow us to add dimensions and annotations to the 3D model, it actually helps us in the process of doing so. Not only that, you don't have to use DimExpert, you can also use your model items. So these are the dimensions that you're adding while modeling the geometry initially, like this 45-degree angle. I can go ahead and capture that and put that into this specific 3D view so that it's also accessible when necessary. So it's nothing more than adding dimensions like we always did in 2D drawings, but we're doing so in a 3D model with all kinds of benefits. So some of the benefits of DimExpert include an auto-dimensioning scheme, which again, you could set up per your document template, tolerancing schemes, default tolerancing schemes, and dimensioning methods. And it will go through and define the features that you have pre-selected automatically. We can also enable the Show Tolerance Status Preview button. And what that does is prevents the problem that I used to run into all the time. I would detail a drawing, I would send it out to the shop floor, or maybe even an outside vendor to be manufactured. And then I'd receive an email back the next Monday. Over the weekend, I was expecting it to be machined up for me, but all I received back on Monday was an email saying I was missing some dimensions for a hole. So I needed to go back, edit the drawing, send it back out, and then wait another few days to have that part machined. The Show Tolerance Status feature highlights each of the faces that have been fully defined by one of the DimExpert dimensions. So you know your job is done defining the manufacturing information once all the faces on the model are highlighted. That is an invaluable feature of DimExpert. Not only that, like think about GD&T. There's so many ways that people interpret it and implement it, where it does have some standards and there is a proper way to implement GD&T. DimExpert continuously checks over 100 GD&T rules to make sure you're not breaking any standard practices. Tall Analyst is something else that requires DimExpert. And actually, I need to correct this slide. In 2016, we've made Tall Analyst, the add-in that was previously only available in Premium. We've made that available in 2016 to everyone with SOLIDWORKS Professional as well. But that allows us to perform a tolerance stack-up analysis using the DimExpert dimensions that we've added to the model. So, all these benefits, what are you waiting for? You've had this functionality, DimExpert, since 2008, so there's no reason not to adopt it. Even if you want to continue to use 2D drawings, you could still use DimExpert to generate the annotations for those 2D drawings. Here's what that process looks like. You're going to use the process that I just demonstrated to add the dimensions in the 3D model. You're then going to start a new drawing. And before you drag and drop your views into the drawing, you'll notice a checkbox to import annotations, and specifically you want to import the DimExpert annotations. From there, you're going to see all your views populate with DimExpert annotations, and they might be disorganized at first. But if you were around earlier today when I went over my favorite tips and tricks, one of the options is to select a dimension, then hit Control-A to select all dimensions within a drawing. And then from the pop-up menu, this is called the Dimension Palette, there's this Auto Arrange button that allows you to automatically arrange each of the dimensions so that they're equally spaced apart following the standards that are specified in your document template. And just in those few clicks, importing annotations, placing your views, and then automatically arranging them, you can have a fully detailed 2D drawing utilizing those DimExpert dimensions. What's so great about that? Well, number one, you're getting all of the benefits that I previously showed on the previous slide. But number two, when it is time to implement MBD, you do so seamlessly. You've already got the dimensions and annotations applied to the model. You're just using MBD to organize those into 3D views so that you could go ahead and make them easily consumable. So to organize them, I'll point this out. We do have annotation views in the standard version of SOLIDWORKS, but what MBD really enables is the 3D views, which control so many more parameters that are critical for, again, producing this in a format that's easily viewed and consumed by someone maybe out on a greasy shop floor with a touchscreen tablet or a computer monitor without having to click a bunch of buttons and reorganize things. They're just clicking on the views that they need and it's already displayed appropriately. Some other functionality that's exclusive to SOLIDWORKS MBD, besides the 3D views, is a dynamic annotation views. So you saw how we could create a front view, a right view, and a top view and specify each one of those orientations. But we could also have the dynamic annotation view where we could have that big spider web of dimensions shown at any given instance. But as we rotate to the front view, all the dimensions will be hidden that aren't aligned with the front view automatically, and so forth as I rotate the model around to other views. Model break view and the 3D PDF template editor I'll cover in just a second. So with these 3D views organized, you can see, just like views on a 2D drawing, we're arranging each of the dimensions into a view that makes sense. You know, show the hole dimensions on a view for a detail of the holes. Show the location dimensions in a general top right or top view, and so forth. Now, the most important capability of MBD is publishing this into a format that could be shared with anyone, because we want our drawings not to have to be printed out, even though you can print out these documents. We want them to be consumed in a much more logical and convenient manner. So inside of SOLIDWORKS, I can either export an eDrawings or a PDF. But before I export this as a 3D PDF, I want to show you the 3D PDF template editor. So we can have multiple views shown at once. So just like a standard view, a front, top, and right view where they're all linked together and can be rotated independently. So we have a template editor to arrange each one of these views on a 3D PDF however you'd like, and include, you know, a title block and so forth, so you're not shocking the manufacturer with a completely different format. And then all we have to do is go ahead and pick that template and export. You'll see that SOLIDWORKS will automatically rotate each one of the views while generating the 3D views that will be available inside of the PDF. And eventually that PDF will be generated, and here we are in Adobe Reader viewing it, but this could be viewed in any PDF reader. This is a standard PDF 3D format, and I could click between the views to show the specific view of interest. I could even maximize that view to the entire screen, and you see as I click on the 4x hole dimension, it highlights all the corresponding holes. So another layer of associativity and clarity that's available in a 3D document that's not available in a 2D printout. Again, if I rotate the faces while selecting the dimensions, I could see those highlighted faces. And we could even use a PDF like this for the approval process. So we could add areas where other viewers can add notes and so forth. They could save that PDF, and now it could be a place to contain each of those notes along the approval process if necessary. Again, the layout of this is completely customizable with our template editor. We have all the views down at the bottom in this case, but those could be left at the top or on the left or on the right. And we can make this look a lot more like a traditional drawing by just editing these text boxes and locating them where we need to. So yeah, we were able to comply with industry standards. By the way, that PDF format is actually specified and required for some of the early adopting MBD and MBE standards that I mentioned earlier. And why is that? That's because, you know, CAD viewing systems may come and go, and CAD software might be swapped from one to another, or something like that over time. But PDF files are as long-lasting of a file format as we have seen and as we expect to see in the future. We don't see PDF file format going anywhere, and it's as universal of a file format as available for, especially for 2D geometry, but also for 3D geometry as well. So that wraps up the workflow that's required for creating an MBD document. Again, DIM Expert is something that you have today, and there's nothing stopping you from adopting it right now and using it still to create 2D drawings, and then eventually when you adopt MBD, you can go ahead and create the 3D manufacturing documentation. But then we can organize with MBD and export it either to an eDrawings file or a 3D PDF that anyone can open. The final thing that I want to leave you with is a simple case study, again done by the supplier of the government, and just to see the staggering amounts of time and money that's saved by putting the information directly at the source of that information. Why create another document that is communicating what's in a 3D model when we could store that information directly within the 3D model? That's a common sense that's being applied to MBE and MBD, and that's why SolidWorks is providing a solution to all of its customers who either need it today or will need it in the near future. So that concludes my, my portion of the presentations. Next up is Roy of Design Point to cover our simulation package. I hope you stick around for it. And we'll be transitioning at 3:30 on the nose to Roy's presentation on simulation.